Place 2 inches in. The first half. This is the second half. Okay. So we see that, let's go over the problem statement really quickly again. So the problem statement here says that we have basically n characters of n lowercase characters. So the first thing you do first, like list out all the variables. So n is less than 20,000, right? And a moo is defined as a substring of like basically a, b, b, where like a and b are different characters. And Bessie moves a lot, so yeah. So like basically, we have to look for any like the number of strings. Like we have to look for the number of potential ABBs whereby from like where we're allowed to do one change on the original array, and we want to have at least 5 ABBs. Okay. So we have here that. So let's first look at the samples. So the first thing to do for every problem is to look over the samples. So first sample is pretty straightforward. There can only be one option, and the one option doesn't require any modifications, right? So we already have like two like MMOs, like MMOs here, MOOs, and then they're already in the original array, and we don't have to change anything to keep them. So this problem, it doesn't really change anything. Second case, we see that if we have MO, let's write it down. MOMOOBAA 2 3 and then QQQCQQ. And we need at least 2 occurrences. So we see originally, so basically AQQ, we can turn this A into a Q, and we will get 2 AQQs here, right? So this one and this one by doing a modification. However, we can also do different modifications. We can instead turn this A into a B, and we'll get 2 BAAs, right? So that's another possible one. And the third one is turning this Q into a C, and we'll have 2 CQQs. Okay. So that's our 3 possible explanations. And so first off, like let's see, like our first potential solution is let's try turning every single possible character into any other possible character, right? So let's just loop through the entire array, and every single time we do change any character into like any other character, and then we loop through the array one more time, and then do a quick count over how many occurrences of like ABB there are. Where like ABB are not actual characters; they're just like representations of characters. Okay, so first case, let's first of all we have to think about the time complexity of that. So it's going to be n changes. 26 options for every single change, or 25 options, because you can't, there's no reason to change it to itself. Actually, there's no reason to change it to itself. So it's n times 25, but then to query the whole thing, it's another n. It's another n operations, right? Because to query the whole thing, we have to look at this, then look at this, then look at this, then look at this, and basically do all these operations. So in order to do this, wait, I think, did everyone, okay. So in order to do this, so the number of operations here are actually going to be. Wait, can everyone stop drawing on the whiteboard? I think we need to. How do we change the settings? Okay, yeah, no, you're good. You're good. Just Okay, it's fine. Okay, so basically the time complexity of this is going to be O of 25n squared. Well, let's not use big O, because technically big O should just be O of n squared. But so n times 25 times n is going to be equal to 20,000 squared times 25. And we can just tell that this is going to be way too big. I think this is around, this is like 10 to the 10th, I think. Yeah, this is 10 to the 10th, which is obviously not going to pass, but this is going to pass the first sample. So first of all, like if you really got stuck in this problem, I think this was a pretty easy solution for this problem, where it's just 10 to the 10th. Where it's where it's 25n squared passes for n less than 100, but this is not going to pass for the main solution. So the main observation we have to make here is that although the number of possible changes we can make is really huge, right? There's n possible changes we can make, and n squared is obviously never going to pass. But we have to notice that the total number of combinations of ABB is not that big. Or like actually like I'll rename this to C1, I'll use C1, C2, C2. This is not that many combinations. In fact, there's only so if we choose the first character to be anything, so this is 26. Second character can also only be another character. So C2 has 26 options. It has to be different as well. So it only has 25 options. So total number of options is 26 times 25, which is 650. So there's actually only 650 possible combinations of the possible answers. And now, if we just quickly do the math, we see that 650 times 20,000 is around 12 million-ish, which is going to pass in time. So now let's try to think of a way we can potentially get a n times like just 650 solution. So first off, if we fix the number we want, if we fix like the combination we want, let's say we fix for this problem, we fix it to be AQQ, yeah. So first off, the first step is to loop over and identify every single AQQ we currently have. And obviously, if we already have AQQ, there's no reason to potentially disrupt it and turn it into another, because there's no reason to lose one AQQ to get another AQQ, right? Because that means that our answer is not changing at all. So we fix these and basically just make these off limits. So this is the first. So we loop over it, and yeah, we want to make sure that we don't modify any of these characters. Because if we modify these characters, if we modify these characters, we're going to not increase our answer at any way. So then the next step is, so after this initial loop, we mark these characters off limits, but then every other character can be modified. Then we loop through it again, and for every single 3 characters, we just see if these 3 characters can be changed into AQQ. So how you actually do this is just you just do a couple if statements, right? So you see if the first 2 characters are uncertain, if the first character matches this one, second character matches this one, then the third character can be changed. Or if these 2 match, then this one can be changed. And regardless. So you just do 3 cases. And if we loop through this, right? So this AAA cannot be changed to AQQ, but if we keep looping through it, this CQQ can be changed to AQQ, right? Because these two match up. The first one's different, but yeah, we can just change one character, change this to A, and AQQ gives the answer. And so if we find that you can change it, then we add 1 to the answer. So the answer will be 1 + 1 = 2. And then we compare this to F to see if AQQ is a potential answer. One mistake I myself made on this contest was I thought initially that basically I could take any single, basically I could do this all in one loop, basically seeing that I thought initially that I could basically loop through the whole thing, and I thought that no modifications would basically change pre-existing modifications. So for example, here I thought that, okay, because this is AQQ, I basically just looped through the whole thing and tried to change this to AQQ. But that doesn't actually work because, yeah, the issue is that a modification to create a new answer, right? So let's say the target one is still AQQ. This will create a new AQQ here, but in doing so, we got rid of this previous one. So the most important thing to note is that doing a modification to create a new target can get rid of an old one. So you have to do a loop to begin with to basically mark all these pre-existing ones as off limits before doing the loop on the whole thing. Again, to check for any modifications that can be made. Okay. Does anyone have any questions about this? Mhm. I think in general, like the main observation of this problem is the fact that like n is too big, but the total number of possible answers is less than n, right? The total number of possible answers is just 650. So in doing so, we basically can replace one of the like the n in the time complexity with a 650 in the time complexity. And that's what makes this problem a lot more solvable. Okay. If no one has any questions, I'm going to basically just do more of a contest recap now. Okay. So this contest was kind of unique in that all three of these problems were ad hoc problems. Like you can kind of call the first problem like maybe a math problem, but even then it's not really. Like it's mostly just you have to make the observation that, you can't actually get the yeah, you can't actually loop through all of n and you have to like do some like an observation to instead group the numbers into like broader categories. And yeah, so there's no real like algorithm knowledge or anything needed to this contest. So in some ways it's easier. The code here was pretty short. Like for example, the code I think problem two I heard was the problem that gave most students like issues. But if you like yeah, if you actually have to make the observation, the code ends up being like only a few, I don't know, like only like a few lines pretty much. Like so the code is really easy, but you just have to have the knowledge to like make the observation. So Ethan, the projected cutoff score, honestly, it's really hard to say. Like I haven't spoken to enough students about question two, about the contest to see like how they did. Like I'm gonna guess it's probably around 750. Like I don't think this was that hard of a contest, but then again, it also might be like because yeah, like if the observations were made, it becomes really easy. But for question two, right? If the observation wasn't made, it's like yeah, like I think if the observation wasn't made, the problem becomes pretty tricky. But even so, I think like it was pretty easy to get partials on all the problems, right? So the second problem could have been done with the second problem, yeah, the second problem, I think the first two test cases were doable without the observation. It was n less than or equal to 100, q less than or equal to 1000. That one was doable by just brute forcing, simulating the whole cube, and just yeah, and just basically just checking it every single time. So I think the cutoff should be around the 750 range, probably, if I had to guess. But I'm not too sure. But okay, so the main thing to take away from this contest is yeah, just get more practice in, like try to build your knowledge of like seeing more types of problems and just like seeing the like problems building problem solving skills required in order to make these observations. Um and also a second really important part is being able to code the brute force solutions. So I think for all three of these problems, there was a pretty simple brute force for like half the test cases. So problem one, it was just obviously like all three of these problems were just simulation problems if you didn't have to make the observation. So problem one, you just like loop over, check every single number. Problem two, you just simulate the whole cube and just check every single column every time you make a query. Problem three, you just like loop over the whole string. You try every single modification, and then you yeah like loop over again to check. So like we see here like this really easy brute force simulation solutions for all three of these problems without the observation. And I think that if you solve two problems and just do the brute force for the last problem, you probably will pass the contest because I think that'll give you around like over 800 points, and 800 points yeah passes any single contest. So yeah, I think that's the main takeaway from this contest. Just get more used to more ad hoc. I think ad hoc's probably gonna appear more and more on USACO, and also yeah, just be ready to code the brute force solution to get any points you need. I think that's which are we going to the next slide? I think that's pretty much all I have to say. Okay.
Okay, yeah, thank you, Alex. Hope all of you learn from the solutions and keep improving your coding skills. I like to say USACO contest is the way for you to learn and improve your coding capabilities. It's the way to show your learning. I think the learning coding goal to pass USACO is just one of them. If you pass or don't pass, sometimes it doesn't matter. If you know the skills, it will help you grow. At XCamp, some of you already know our achievements in the past almost 8 years. We have 300 more students passed in the silver and above, 60 in the platinum division, 27 joined the USACO finalist. 2 of them got European Girls Olympiad Humanities medalist. 1 got IOI, International Olympiad of Humanities good medalist. Last year we have 11 students got MIT offer. This year we just heard the ROI student, he just got an offer from MIT too. Yeah, USACO is a long journey. Hope you enjoy that. At XCamp, we are here to help you and support you. So we have on-site camps. It's coming. The winter camp, we have December 26th to 30th. It's in South Bay, San Jose. If you are interested, you can join our USACO Bronze Camp. Also in the summer, we have another 2 weeks from late July to August 2. We have year-round weekly classes. We have 4 quarters a year, 10 weeks for each quarter of the class. Also, as we showed last slides, mock test is one important way for you to practice, especially to prepare the USACO contest. Sometimes you learn this knowledge, but you need to practice to how apply them. Also, we have Grandmaster classes that's mostly for the USACO Gold and Platinum level. Also the US Camp and the IOI. Also, we have APCSA series. If you would like to pass APCS or got 5 in APCS, we are here to help you. This kind of journey. If you are interested in USACO journey, XCamp may be one of your good choices. Okay, that's good. Thank you all. Hope you are continue learning coding. Also, for this season, there's 3 more contests coming. If you have any questions, you can reach XCamp staff, faculties. Yeah, thank you.